Thank you so much for your time. I feel very privileged to be part of this wonderful gathering, talking about something that is really so important. I stand before you wearing a number of hats, and I just want to quickly clarify that. I designed the original solution that reflective learning is scaling, but I'm not involved in the company component of it as such. I'm a researcher at BITS. I'm using the reflective learning data to be able to share the findings that we are finding. Reflective learning is made up of two parts. There's an edtech company that is actually taking the solution. We're currently working in 2 other countries, Australia and the UK. But my heart is here, and we have a reflective learning foundation that is working with organizations here in South Africa. But in my heart, I'm a teacher, will always be a teacher. I have deep love and care for young people and learning. I'm an absolute learning nerd. And so the opportunity to share with you, I'm very grateful for. I'm hoping that I can manage the slide component. I don't know if you are familiar with this paper, 2015, Nick Spall and Yanni Kotzer brought out a paper called The Case of Insurmountable Learning Deficits in Mathematics. And I have been working for 3 years already on a project in Mpumalanga, and this paper resonated so deeply with me. It presented exactly what I was seeing. Spall and Kotzer found they were able to devise a statistical measure of backlogs, and they analyzed 3 different data sets to be able to present these learning trajectories for grade 3 to grade 9 learners. And this wasn't a statistical estimate, but they were able to say that the grade 9 learners were actually 4 years behind in reality. And they show the y-axis shows you the effective grade. That's the grade that the learner is functioning at, and the bottom actually shows you the actual grade that the learners are in. Now, I had actually been working with a direct measure of learning backlogs also in units of grade years, and this mirrored exactly what I was finding, and so I was absolutely fascinated by it. What they found, just to highlight if you're not familiar with the paper, there were 2 really important things they found. The first was that only 16% of South African grade 3 learners are actually at grade 3 level. In other words, 84% of grade 3 learners leave grade 3 without the foundational knowledge that we expect that they would have acquired. And also that the poorest 60% of learners in South Africa are 3 years behind the wealthiest 20% in grade 3. And that this gap grows to 4 years by the time of grade 9. So I'm just going to skip to the work that I was doing at the time because it aligns. I use an instrument that I developed myself called the Reflective Learning Diagnostic, RLD, and this instrument is a set of diagnostics that measures, first of all, it tests only one concept per question, so it's possible to pinpoint exactly where learners have got stuck. There are 81 fundamental concepts in maths that are developed vertically through from grade 1 to grade 9. There are 25 of them that are covered in foundation phase. Those 25 plus more bring it up to 60 for grade 6, and then plus more, another 21, brings it up to 81 in grade 9. And each question benchmarks a learner at those phase levels so that I can see where their last place of secure knowledge is to be able to then give them what they need at a concept level. So this tool, now that it is a digital tool, is generating enormous amounts of fascinating data. And just to give you an idea, this is the data that we collect. Sorry, I'm just trying to keep up here myself. We have the actual grade that the learner's in. That's the grade they're enrolled in at their school. Then we measure the effective grade of each learner for each of the 81 conceptual landmarks, the key concepts that they need to master that are required for math success going forward. From that, we have an algorithm that calculates the effective grade of each learner for each of the 7 conceptual threads. We have 7 conceptual threads that run vertically through the grades and connect those 81 concepts to each other. And then we have an algorithm that can actually take the grade level of the 7 conceptual threads with a weighting that allows us to put the learner overall on an effective grade. And then the difference between their actual grade and the grade that they're actually performing at, that is a measure in grade years of their backlog. So, there we go. So I think the reason why I was invited to this is that I presented a paper at SAMSTI in January that I was asked to share with you. And it's relevant because the sample comes from KZN, but it's a nationally representative sample. So what happened is an NGO operating in your province used reflective learning at the beginning of 2019 to just do an investigation into schools in 2 districts that they were involved in. The 2 districts were your King Titsweo and Pinetown, I think was the other one. There were 22 schools, and those schools represented all 5 of the quintiles. And then within each of those schools, they were looking to see what the state of maths was across the 5 high school grades. And the learners' names were generated randomly in each grade at each school. So there were 25 grade 8, grade 9, grade 10, grade 11, grade 12 learners from each of the 22 schools, and that makes up the sample. And so the reason why this is also, I make the case for it being a nationally representative sample, KZN actually in 2019, the overall average was exactly the same as the national average on the National Senior Certificate. And in maths, the average in these 22 sample schools was 54.2% compared to the national 54.6% of learners passing maths at 30% and above. And so it was a really interesting sample to consider, to get an idea of what might be happening. I was very interested to know, School and Costa showed us that grade 9 point. I was interested to know what happened in grade 8 and what happened up till grade 12, because grade 12 is where we face our problem. So you can see the breakdown of the number of learners from each of the grades. There were 2,522 learners. The reason why they're a little bit less than if you add up all those numbers is that learners who didn't complete anything or who actually didn't answer a minimum number of questions were excluded. These are only the learners who actually answered all the questions in the diagnostic. So now comes not quite yet. So in terms of the data analysis, the learners were disaggregated into the grades 8 to 12, and they were also disaggregated into the school quintiles within the grades. And then I calculated the mean effective grade and the mean backlog for each actual grade and for each actual grade within the 5 different quintiles, so that I could find out more about their backlogs. So I'm afraid it's not great news, but you know it already. But this is interesting because it's drilled down now, and you can see the detail. So in my table on the left-hand side, you can see the actual grade of the learners, and they're the numbers of the learners that are assessed. And the scary part is to look at these learners, the percentage of learners that are not exceeding grade 3 proficiency. So a quarter of the grade 8s are actually functioning at grade 3 level and below. And you can see that even in grade 12, there are some learners doing maths who are functioning below grade 3 level. Overall, 10% of high school learners have not mastered foundation phase. And when you look at the last column, this is looking now at grade 6 level. Almost all the grade 8s and grade 9s are not at grade 6 level. They don't have the maths skills and competencies of grade 6 level. And even 2/3 of the grade 12s are functioning at grade 6. So for me, this explains a lot of the problem that we have, because if you don't understand maths and you can't do the basics, you cope by rote learning, you do past papers, you acquire two very useful skills for yourself. The one is to be able to recognize a type of question that requires a certain procedure to solve it, and the second is to be able to administer that procedure. And that's why you can have learners that actually matriculate and they can't do maths. And they go to university and they've got good marks. I don't know whether you're familiar with the work of Professor Sue Ellen Shea from UCT, but she was, unfortunately she's passed away now, but she had been tracking first year maths scores at UCT in engineering and the sciences. And she was looking at what the learners got in grade 12 and what the learners did at university. And I'm sorry to say that it's a bit like the primary school learners getting 90% and the high school learners doing much, much worse, because she found that in first year, learners who are admitted to those STEM career courses that are, have got a B in maths, in other words, 70 to 79%, 2/3 of them fail maths 1. Only 1 in 3 can actually pass first year. And even more scary, we highly praise a distinction in maths, but learners who are getting between 80 and 89% for maths in the grade 12 exam, their average in first year is 47%, which is 3% below the pass mark. So we have a systemic problem, which is why something like this gathering is so important, because we need to talk to each other in all the bands of learning through, from the very start to our exit point at grade 12. So just to summarize, I would like to share a little bit of hope with you as well, because I hate being a prophet of doom and gloom. So if you just bear with me while I go through a little bit more of the doom and gloom. So you can see that when I plot the results, what's really nice is that the grade 9 data anchors the same as school and COTSA. And so I didn't know that that was going to happen, and I have to tell you that that grade level is rounded off. It was actually calculated at a grade level of 4.7, which was identical to school and COTSA's calculation of 4.7. But I can see now that, yes, the grade 9s are 4 years behind, the grade 8s are 4 years behind as well, the grade 10s are 5 years behind, the grade 11s are 5 years behind, and the grade 12s are 6 years behind on average. And notice that plateau of grade 6. I believe that's the heart of our problem. Grade 6 is a ceiling of proficiency that we are not getting our learners past. And I would like to talk a little bit more about that in a moment. I just want to drill down and share a little bit more interesting insights that the data gives. Okay, so these are the 7 conceptual threads that are assessed in the diagnostics. There's numbers, being whole numbers and integers, and then number operations. There's fractions, decimals and common fractions, proportion, ratio. There's measurement, there's data literacy, there's problem solving, and that is problem solving in the true sense of visual reasoning, spatial reasoning, deductive logic, all those components, because in my experience of working with learners, problem solving doesn't come right unless you actually teach problem solving strategies. That was a misconception I had as a teacher that I learned from my practice was not the case. And there are patterns in algebra and space and shape. And I just want to draw your attention to a few things. You can see that the reddish line shows grade 8, and the sort of yellowish line shows grade 12. So that's the value add going through high school, which is quite scary. Learners come in at a grade 6 level, in grade 8, they function at grade 6 level in numbers, and they gain 1 grade level of proficiency in numbers in 5 years of schooling. You can see, I'm going to skip a bit because I want to draw your attention to different things. Measurement is, the grade 8s acquire 2 years of proficiency in measurement skills. Data literacy is the most successful of the threads, and I think that is because it's reinforced in so many other subjects. So they do data literacy in geography, they do it in science, they do it in biology, and you know, we live in a data-rich world, and I think that they have a lot more richness of input in that. And then space and shape. Grade 8s come in at a grade 4 level, and grade 10s leave at a grade 7 level. But look at patterns and algebra, and look at fractions. They're identical. The grade 8s come in at a grade 3 level in both fractions and algebra, and the grade 12s leave at a grade 5 level in both of those. And you might wonder, oh, how can they be? They're doing very complicated algebra. They don't understand it, though. They're doing it, but they don't understand it. And therefore they can't use it. And so I want you to look at that similarity, because there is so much literature about the connection between fractions and algebra. Fractions we target in the intermediate phase. We're not getting our learners past the intermediate phase. And I just want to throw a little idea out there. We focus so on number sense. It's so important that learners are flexible and fluid and can work with numbers. They need to be like that with fractions as well. They need to be able to mentally work with fractions, common fractions and decimals, perform those operations, estimate with those numbers. And we don't have time to do that. We just do a kind of formulaic, this is how you add, this is how you subtract, this is how you multiply, this is how you divide. They never get a proper deep understanding of that. Sorry, I'm trying to make sure I don't get off track here, and so I keep losing my place. Just out of interest, I don't want to dwell on this, but I found very little difference between the quintiles. And I must tell you, looking at the reflective learning data, this is not a public school problem. This is in the fanciest independent schools, we still see learners that are very far behind. We have a culture of rote learning and preparing and thinking that is learning. We don't actually really understand what learning is as a nation. And one of my little pet hates is when we say, I'm going to learn for the test. If you learn for the test, you don't know what learning is. We prepare for tests, we practice for tests, we rehearse for tests, but we learn for life. We learn for ourselves, we don't learn for tests. And we need to be aware of this culture that is measuring success on a test, because what's happened is that tests are no longer measures of learning, they are goals of learning. We aim to be getting scores on tests. We don't aim to be learning so that we can demonstrate our expertise on tests, and that's my dream scenario for us to be in. So just to summarize, 80% of South African high school learners are left behind at a grade 6 level of overall mathematical proficiency. And that alone is a takeaway of value, because if you treat your grade 8s, your grade 9s, your grade 10s, your grade 11s as being at a grade 6 level, then you know where to start with them, with whatever it is that you're doing. You need to track back for the key concepts that you're going to use in the lessons for mediating the learning at the grade level, and make sure that those concepts are in place. Or at least address the issues around them, because otherwise you've lost them before you've even opened your mouth. Fractions and patterns in algebra are where learners are struggling the most. Learners are not developing their problem-solving skills through the high school grades. I didn't pay attention to showing you that, but you can see they came in with a level of problem-solving skills. The grade 12s had exactly the same level of problem-solving skills at the end. They learned no problem-solving skills in 5 years of schooling. In maths, a problem-solving activity. So catch-up interventions really need to prioritize the building of conceptual understanding and the flexible and fluent manipulation of fractions, decimals, percents, ratio, proportion. I just want to mention, there's a researcher called Wu, W-U, and he has done a lot of work on the relationship between a solid foundation in fractions, and I'm referring to common fractions, not necessarily decimal fractions, and algebra. And he sees fractions as a critical transition for being successful in algebra. And so if we've got problems with kids in algebra, I have a little example, unfortunately I'm not going to have a chance to show it, of a grade 9 algebraic problem. And if a learner gets it wrong, you might think, oh, they can't do algebra. But when you unpack it, you can see that there are 12 fundamental concepts in that, of which only 2 are related to algebra. And those other concepts are all key in being able to solve that algebraic problem. I just want to mention, just to say that, you know, in their paper, Small and Cotter obviously drew attention to the fact that it's really important to be building a solid foundation in the first years of school. I'm not taking anything away from how important that is. It is absolutely fundamental. I think that we are doing a lot of that well in ECD and foundation phase. My concern is what we're doing or not doing in intermediate phase. We need to be building understanding in intermediate phase, not presenting the content as facts and procedures. We need to be developing the understanding of what they are. There's a famous mathematical researcher, Lemon, who made this very controversial comment that 95% of the world's population can't reason proportionally. Now, I mean, the heart of proportional reasoning, multiplicative thinking, it comes out of fractions. It comes out of understanding fractions, and we need to focus on that, because to do maths without multiplicative thinking is not possible. One of the teachers yesterday spoke about how important multiplying and dividing and working with fractions is, and I couldn't agree more. There's another interesting researcher, Usikin, who has identified 7 key transitions that happen in the intermediate phase years. And if those transitions are not navigated successfully, learners can't be successful in maths. I would love to share some of these papers maybe after this, so that you can read the originals, but this is where we really need to focus our attention. I don't want to take too much more time than, sorry, I need to press through. There we go. I just want to quickly I'll get that one back. I just want to quickly share something, because as I said, I don't want to be standing here telling you about the doom and gloom, because this is the story that actually changed my life in the work that I am doing, and has focused me on what I'm doing now. I was doing a lot of monitoring and evaluating of donor-funded interventions. I was living in Mpumalanga, and I was working with an NGO called Uplands Outreach. They had funding from the Rand Bank to have 5 learners from each of 10 high schools in the Nsakazi circuit, which is a very impoverished little community near by the Kruger Mpumalanga International Airport. And I chose to design a diagnostic baseline assessment because the grade 9 ANAs had shown that in Mpumalanga, grade 9s were achieving an average of 9% on the ANA. And I was very worried that if I did a baseline and nobody got anything right, we wouldn't know what to do. So that is actually where the reflective learning diagnostic was born. I identified these key concepts. I set the diagnostic benchmarking grade 3, grade 6, grade 9 levels, administered it to these learners, and yeah, terrible shock when saw the results. As you can see in fractions, the red shows learners that are functioning at a grade 1 to 2 level. The orange shows learners functioning at a grade 3 to 5 level. The yellow shows learners functioning, the percentage of learners functioning at a grade 6 to 8 level, and the green, the little 2% in data handling and numbers, shows the learners that are actually functioning at grade 9 level, and the learners were in grade 10, and they had chosen to do maths. So to save the project, I stepped out of my M&E role into teacher, and I had the learners, for 50 of them, for 1 hour once a week to catch them up while the grade 10 enrichment program that had been devised for them was going to continue concurrently. So it was a kind of a race, and I would love to talk more about the metacognitive approach, but my focus of catch-up is around developing metacognition. I developed a quantitative measure of metacognition so that I can track learners' metacognitive progress, and it involves sharing all of the data with the learners, analyzing with the learners, sharing pedagogical insights, teacher insights with the learners, because ultimately in high school we are handing the baton of learning over from ourselves, the teacher, to the learner. We want learners to be accomplished learners in their own sense by the time they leave grade 12. That's our core business, actually, is teaching learners how to learn for themselves. So I'm not going to dwell on it, but essentially 4 school terms later, the learners had caught up, mostly caught up their gaps. I was disappointed with the fact that some hadn't. I had to take an extra term with problem solving, and I had to take an extra term only with fractions. And the others were actually quite easy to catch up. Catch up is easy. If you know where the problems are, the learners know where the problems are, then they are actually able to get from where they are stuck to where they need to be. And that's the message I want to leave with you, because this group of learners, there were 50 of them, they wrote their National Senior Certificate in 2014. We had 3 times the national average on pretty much all the important measures. 9% of them got maths distinctions. And I want to just mention at this point, sorry if I'm taking too long, but I feel this is really important. Sometimes when we are involved in interventions, we look at a group of young people and we say, oh, these kids have got potential, I'm going to take these kids off and I'm going to give them, put them in a special program or whatever, and see if we can improve them. I learned that you cannot overlook anybody. I had a boy in this group, his name is Mankoba Nyati. He He scored at a grade 4 level on that first diagnostic. The top learner was at a grade 6 level. Mankoba was lost in the middle of the group. He developed an incredible love for maths. He matriculated with 93% for maths. He got an SASA bursary to study to become a teacher. He is teaching in his community at the school that he matriculated from. He's the acting HOD, and he's only 28. So I look at every child as a potential Mankoba, and I urge you to do the same. Don't take just the top, because circumstances in our country have meant that there are so many talented youngsters who have not been given the opportunity to show their talents. Just to quickly, it's a little bit of boasting now, sorry, but more than half of them are orphans and vulnerable children. We got funding for 29 of them to go to university. All of them passed first year university. And we managed to get more in the next year. But I'm in touch with 40 of the 50 still. They are my friends now. 15 of them are teachers. I say almost all maths teachers because there are 3 of them that are foundation-based teachers. They are maths teachers, but the rest are all specialist maths teachers. They only teach maths and science and geography, I think, are other subjects. Some of them teach with maths. 8 of them are engineers or engineering technicians. We have a medical doctor, there she is over there. We have a pharmacist, biochemist, 2 nurses, 4 IT specialists, one of which runs the IT centre at Uplands College, 4 agricultural scientists, economists and technicians, 4 working in environmental affairs and tourism, and 4 in business. One's a business owner, managing, marketing, and selling. So the message, sorry, oops. Sorry, I've gone right to the end of my thing and I don't really want to take any more of your time, but I think the message is that yes, we're in a tough situation, but there is a solution, and the solution is to know where learners are and to be able to give them what they need to be able to bring them up to grade level so that they can access the teaching that we provide for them at grade level. Thank you so much.